Good afternoon, everybody. How are you all doing? Welcome to Sushi Tech Tokyo 2026. This session will be the battleground for autonomous driving. Shifts to software, the race to build the brain of passenger vehicles. I would like to invite on to the stage our profound guests. Please welcome our speakers. Eunice Kassar, Applied Intuition. Hiroshi Sato, Isuzu Motors. Kazuma Sugimoto, Nissan Motor. Tomoko Echizeya, Yomiuri Shimbun. The floor is yours.
Welcome to everyone. 皆様、本日は寿司テック東京2026年にお集まりいただき誠にありがとうございます。本セッションの進行を務めます読売新聞の越前と申します。10年前、自動運転が語られる際、議論の中心にあったのは、主により高性能なセンサー、より強力なチップ、そしてより高度な車両といったハードウェアでした。しかし、現在、根本的な変化が起きています。乗用車から商用トラック、建設機械、物流フリートに至るまで、機械が認識し、判断し、行動するということを可能にする基盤として、ソフトウェアが主役になりつつあります。これがいわゆる SDV への変革です。本日はこの変革を3つの異なる視点からご紹介いただきます。まず、乗用車の分野から、技術の日産、そして次世代プラットフォームの開発を牽引なさっている杉本和馬さんです。よろしくお願いします。続きまして、商用トラックの分野から、社会課題、物流には人手不足ですとか数多くの社会課題がありますけれども、そちらに対処すべくレベル4の自動運転に向かって指揮を行っています。
He's leading the effort to level 4 technology. Mr. Hiroshi Sato is here from Isuzu. And from the AI software infrastructure side, we have Mr. Kassar Yunis from Applied Intuition.
Thank you for having me. それでは、これから始めさせていただきたいと思います。
Okay, let's begin.
ここから、まずですね、すいません。各社の取り組みと
Well, first of all, I'd like each of you to briefly share your organization and where your organization is today. In the autonomy journey, maybe from Sugimoto-san, from Nissan Motors perspective, where are you today in the journey toward autonomous vehicles? Yes, thank you for the question. First, what stage are we in? If I answer your question straightforward, in 2027, mass production and commercialization will be our aim in our current development. And this has been already announced to the market. In 2027, the AI-driven autonomous vehicle will be introduced to the market. And this technology will be used and applied for robo-taxi. And this is another announcement we have made today, the other day. The way we have been looking at autonomous driving is different from 10 years ago. How much sensing capability can advance, that it has been determining the evolution of autonomous driving, but AI helped us to make this evolution much faster in an exponential manner. In 2027, we will be introducing level 2, meaning that the driver will hold the final responsibility to drive. But the same controller software can be used for robo vehicle. So technical evolution, not just technical evolution, but also because of this emergence of AI, we have all the element technologies. With all these available element technologies, we have to ensure the safetyness and security with the quality to the appropriate customers. We are at the final stage of the product development for that qualifies to the general public. So we thought that would be a long future, but that's not really true. It's going to be very soon. Let me ask the next question to Sato-san. The trucking world is facing very difficult pressures: safety, driver shortages, logistics efficiency. How is that shaping the way Isuzu thinks about autonomy? Yes. The logistics industry is suffering from the shortage of the drivers. According to the estimation, before 2020, over 30% of the items would not be carried anymore. So autonomous driving is not the simple technology that we need to seek for. This is something that is determining the future of the logistics in this country. Isuzu, in 2027, is introducing the social implementation of truck and bus systems to make it autonomous. And this is a very high hurdle for as a management challenge. And we have a tier 4 and for the bus system, and we have a joint development with Applied Intuition on the truck fleet. So we believe that before 2027, we should be able to introduce to the society high quality and safe unmanned level 4 automatic system.
Applied Intuition works across so many industries like automobile, truck, mining, and agriculture, and even construction. So how quickly do you see the industry shifting to software integrated platform?
There is more difference within industries between manufacturers than there is between the industries themselves. So in every vertical, automobiles, trucking, agriculture, etc., there are leaders. If you take, for example, Isuzu is the leader within the trucking space. So it's less between, it's more between the manufacturers. I think the key thing is you see some of the more successful companies in each vertical recognizing how important this technology is and putting a lot of effort into it. So, and that's global, that's not only in Japan.
So, is it happening faster than we might realize?
No, I think it's happening slower than we thought. I think self-driving, I was at Google when the self-driving team was started and funded and grew, and that was over 15 years ago. I think it's taken a longer time for self-driving to get to the market because the old technical approach, specifically pre the Transformers architecture, was not actually the best technical approach. If you look at even Waymo used to have a self-driving car program and a self-driving trucking program, and they closed the self-driving trucking program because it was too different from cars. Then in the last 5 years, a new technology has emerged using this Transformers architecture called end-to-end self-driving. And Applied Intuition, along with other companies who are active in the ecosystem, have adopted this technology, and I think that is the technology that will ultimately take most of these products in these verticals to production. So I think everyone knew the potential of self-driving for a long time, but I think only the technology to do it has emerged in the last few years. So I think that's a very important distinction. And I think the revolution you've seen in AI in large language models, specifically things like ChatGPT or Gemini, the same technology we're putting in self-driving. Applied Intuition actually authored one of the main research papers that takes transformers into self-driving, and now we're implementing it with our partners into production. The last thing I'll say is, in this topic is, self-driving is a very difficult technology. So just like making chips, there's not thousands of companies that make chips. And silicon development has existed for, over 75 years, I mean, in some way or shape or form. And so self-driving, I think, will only actually be done by a handful of technology providers globally, because you need a lot of capital, you need a lot of technical skills, you need a lot of data. And so I think even when self-driving emerges into the mainstream and all of these different verticals, I think there's only going to be a few companies that do it. I don't think it's going to be 100 companies or maybe even 50 or maybe even 20 that do self-driving, just like there's only a few chip manufacturers globally.
And how about social acceptance? So because some people are very cautious about the safetyness or the legitimacy of the autonomous vehicles. So what do you think of it?
Yeah, I mean, one thing is absolutely clear. Self-driving technology is much safer than human driving. This is statistically and mathematically true. But the reality is humans have a higher bar for self-driving than they do for human drivers. Every single day, there are hundreds of people globally, thousands of people actually globally, that die from accidents that involve trucks. Whatever we can do to reduce that, we should be doing that, and self-driving does reduce accidents and fatalities. That's different from social acceptance. For example, it's bad to eat unhealthy food, but last night I had McDonald's. So that's the reality and difference of what is the reality and what's the actual implementation. So I think companies, automotive companies and trucking companies, agriculture companies, mining companies will have to kind of carry that message forward to government regulators and to the consumer. But I can tell you, in Silicon Valley, which is kind of always maybe 6 months ahead of the rest of the world in terms of technology adoption, majority of the people have ridden in self-driving cars, whether it's Waymo or Tesla or some other company, and there's been a huge demand for them, not less, more. So I think as self-driving becomes more common around the globe and in Japan, I think the feeling of safety will match what the reality is. The reality is they're very safe, but the feeling is more fear. So I think we can reduce that.
Thank you. ここからは今回の革
From
新であ
here
ります
on, we would like to
ハー
talk
ドウェアからソ
about
フトウ
the
ェアの
shift
シフト
from
を
the
深掘りい
hardware
たし
to
ま
the
す。
software. I'd like
こ
to
れ
go a
まで
little bit
長
in
年にわ
deeper.
たり
For
車
the
両はハ
longest
ードウェア
time,
製品とし
the
て捉えられていました。
vehicle
しか
was
し今や
considered
車
a
両は
hardware, but
現実
now
世界と相互作用するソフトウェア
this
シス
is
テムと
actually
変
the
化してい
software
ます。
system which has
So
the
vehicle now needs to learn,
conjunction.
improve, and update continuously, which puts software at the center of the development. So, Kasao, regarding this transition, what does it truly mean to build intelligence for machine in the real world?
Yeah, I would think about this concept of putting intelligence or self-driving into physical machines as a multi-part technical problem. One is what we already talked about, which is the models that run the self-driving system. The second is the actual software that runs on the car in order to run applications like self-driving. So in your phone and on your laptop, a developer can make an application for because of Android and because of iOS in a very simple way. They don't need to be concerned with the memory or the power supply of the laptop or the phone. That's not the case if you're making software for a car or for a mining vehicle or for a truck. And so the second thing that you need is an operating system. And so you have the application, you have the operating system, and then you need the operations around the actual intelligent machine. So imagine if you are working in a port, or if you are working in a mine, or if you're working in a trucking hub. There is software that's around to organize all the machines. And so when you think about these platforms, I would think about it as all these separate problems that need to be solved individually. But one of the biggest ones is, can the car, truck, whatever the machine is, can they actually run intelligence on top of them? And that's what the software platform is.
So is it so challenging for individual companies to build this entire software stack on their own?
I think everything is possible if you have unlimited time and you have unlimited money. So everything is possible. Yes. But if you look at the phone industry, manufacturers used to make their own operating systems. Mm-hmm. And I think ultimately the reason Android and iOS exist is because they're maintained platforms that run on Android runs on thousands of different pieces of hardware. And so that's kind of our strategy for Applied Intuition, is we can provide both the applications, the intelligence, and the actual platform. But every manufacturer will take a different strategy. Sometimes a part of that platform is bought, sometimes that platform is completely built, but you still need a platform that can run these intelligence applications on top. Whereas on phones and laptops, we don't really think about that because the platform is already done, which is iOS or Android.
Thank you. それでは他の皆さんにもお伺いしたいと思います。
Now, I have a question to the other member, Mr. Sato. In case of the truck, safety as well as operation efficiency is extremely important. Now, AI software development, how do you think that would change the future of the truck? Yes. The commercial vehicle, in case of Isuzu, around 2000, so-called the telematics. We put a lot of effort into this telematics already. The platform we call the GateX to share the information, we already have that. And then we suck the information of the vehicle, put together with the other information, we connect the data, and then we manage the operation of the car as well as the guarantee of the operation. That's called the Prism. Imamori, those are the name of the product, and those services has already been done years ago. However, up until now, it was only one direction. So we give the feedback to the vehicle, but we are not able to do anything with the vehicle, so we are able to manage that. But then, once with the AI and operation, all the information can be utilized to have the optimal way of managing, or maybe how we run the vehicle. We are able to improve all that. And with that, utilizing the data and to connecting the data continuously, we are able to improve or to transform the vehicle. We use a lot of software in the vehicle. And when we create those, the usage is diverse, but we can only make one. So we try to make the optimal situation. But as for the usage, for the users who may use in the different way, it may not be necessarily optimal. But then we also get the information as to how people would utilize and then to analyze. And if we are able to change the control, then depending on how the consumer use it, we will be able to provide the software that's optimal for the users. So when it comes to the efficiency of the operation, I think that can be further improved. Thank you very much. Mr. Sugimoto, as a Nissan, software has been continuously developed. Now, the process of the development itself in the era of AI, I would wonder if that itself has changed. Can you talk about that? Yes, thank you very much. The transformation of the development stage, it has changed up until now, but also with the AI, we have to change even further so we can put them into two different categories. The seen from the SDV, first, the software can be upgraded. or we have the value to the software, so we have to make sure that we evaluate the software. So from that perspective, the vehicle originally was evaluated by the hardware, but then used the cloud, and we are able to evaluate in a digital way. And that's something that we have been doing for years. We would reduce the area of the evaluation by the hardware, but to be able to evaluate on the digital part, we have actually created that. But on top of that, if we were to put the AI, the world's going to change. What I mean by that, the way we were manufacturing things is the logic that we design, that we 100% guarantee and then provide to the customer. We have been able to 100% evaluate what we have ProPilot 1.2 and 1.2. We have the road where we are able to provide the service. We run all of that. But with the presence of AI, let's say if we were to try to realize outside the city, we have to identify all the patterns. We have to 100% evaluate. That is not going to be a possibility. So AI itself, it has have to think and then to generate the output. So we are not able to recreate, and we are not able to 100% evaluate. So the methodology of evaluation, and as to how we are able to guarantee the quality and how we bring it to the market, of course the base is not the physical evaluation, but it's the digital evaluation. So what we have created based on the SVT, the platform is the preposition, but on the digital platform, the quality of the AI, how we are able to guarantee that, and then to the AI model, which is continuously being trained, we have to maintain that the situation is constantly being trusted. And this is the transformation of the process for us to be able to get to a further stage into the future. Thank you very much. So we'd like to move on. Otherwise, we're not going to be able to finish all the questions. The next is about the overall system. I would like to talk about thinking from the systems perspective. One of the big changes that's happening is that the corporation is looking at the system overall, not just element by element. So the sensor algorithm, these individual technologies not sufficient. Software, data, and operation itself, how is it integrated? And that is extremely important as we go forward.
It's very important how the vehicle, software, data, and operation all work together. So let's talk about the scalability. So what does it actually take to operate autonomy at scale?
It takes many things. I think it is worth saying that physical AI, and so AI on vehicles, is going to be a sovereign issue going forward. What I mean by that is, if you look at the history of software, originally, companies like Google and Facebook kind of went global almost without any restriction. And then if you look at mobile apps, there's a bit more restriction, and there's more domestic mobile apps in every region. If you look at AI, I think you're going to, especially AI in physical machines, including defense, this becomes a very important national priority. And so historically, you would have these typically Silicon Valley or American companies export this technology like Uber or like Google, and the local markets would just be consumers. This is not how physical AI will grow. And it's partly because the countries that don't understand AI, and what I mean by that is they can't build and deploy AI in the real world, are going to be at a huge disadvantage, both from an economic perspective and from a defense perspective. And so I think when we talk about operationalizing AI, it's very different actually from many other businesses or many other technologies that have come before. So let's say if you want to deploy AI in Japan, as an example. Well, then you need engineers that understand, number one, the technology. You need a infrastructure, so that might means like a data warehouse or a GPU training cluster. You need data centers. Then you actually need to deploy them on physical vehicles. And then you need the rules and regulations around those vehicles and the operation. So let's take, for example, instead of cars and trucks, because those we've talked about, let's take an example of a mine. And you're automating a mine. That requires a huge amount of all the things that I've already said to implement, and then ultimately to see the value and the increase of efficiency. So my general point being is, I think every country, including Japan, should very much focus on physical AI as a sovereignty issue. And I think it's a lot of subcomponents. It's not only one thing. It's not only data centers. It's not only self-driving. It's not only rules and regulations. But all those things are connected.
Wow, interesting. And so maybe it's very influential when it comes to realization of the autonomous software system. And then you are essentially creating a digital safety net, right? それではすみません、杉本さんに
Thank you. I'd like to now ask 杉本さん。
展開にあたって、
Question 2. I guess autonomous driving becomes more widespread, and changes required not to the autonomous driving, but the entire operation has to change. And the foundation software is also will also play a very important role. And I wonder if you can tell me about Nissan's perspective. Yes, thank you very much for your question. All the functionalities should be integrated, or everything can be distributed. There are a lot of discussion that happens in Nissan internally. And up to now, I guess it's not just Nissan, but all of the legacy OEMs have been had a siloed development. Autonomous driving, cockpit, body, powertrain, all separate groups. That has been the conventional approach. But then we realized that SDV or autonomous driving will not be possible without them, those approach. But that is not true, we understand now. Because of those silos, we thought that integration was needed, but integration is not necessary. When everything is integrated, software grows bigger and it becomes more difficult. Those distributed approach gives us the ease of the development. Then we have to decide where we shouldn't silo and what other things we should silo. And the biggest point is data. Data, when it's siloed and distributed, the efficiency will be lost. So I guess we can keep and develop the logic in each domain, but the data in the car has to be centralized within the vehicle, and it can be seamlessly integrated to the world of cloud so that it can be used for the next software development or for the training of the AI. So data will be the key. We shouldn't just simply say, let's introduce one ECU, one software. That's not the answer. That's not the answer. What should be centralized, what other things should be not centralized. We really have to focus on the difference. When we do that, the AI-driven autonomous driving and AI-driven software development, we will come to the conclusion that the data will be important for both types of development. Now, how do we establish the platform where we can use the centralized data will be our challenge. And then how the platform can use that data that becomes available from the vehicles, off-board, on-board, both platforms technologies have actually been named as a Nissan Scalable Open Software Platform. We have decided to develop those seamless seamlessly connecting
ありがとうございます。
platform between the vehicles and off-board environment.
佐藤さん、すいません。
So that's an ongoing
こちら
effort.
トラックに
Now,
ついてなん
Sato-san,
ですけれども、
if
こ
you
ちらは
are able to
車
share
両
with us about
で
the
はなく
commercial
て
vehicles,
物流システムの一部のような運用をされているという
it's
ふうに伺
now
っているんですけ
used
れども、
not as a
こ
vehicle,
の
but
点
it's
自動運転シス
the
テムが導入
autonomous
される
driving
とどのよ
system
う
is a
に
part of
変わ
your
っていくん
the
でしょう
fleet
か。
system,
はい、
the
そうですね。
logistics system,
今
how
我
the
々は
change
いわゆ
would
る幹
take
線輸
place.
送、高速道路の
Well,
幹線輸
currently
送のレ
we
ベル
have
4の大型トラック
level
というのを
4
開発しているんですけれど
highway
も、これ
the
は先ほど言いました
transportation
通り
truck is
27
being
年度に
developed,
は
and as
社
I
会
said
実装でき
earlier,
ると思ってい
before
ます。ただ
2027 we
物
should be able
流
to
はです
deploy
ね、
it. But in terms of the
弊
logistics,
社では物流は血流だとか言ってるんですけ
we
れども、
always said that the logistics
日本の
is
端々ま
the
で
blood
物流があり
flow
まし
of
て、
Japan,
物
and
流
the
が止まる
logistics
と
everywhere, all
物
around
も
the
作れな
country.
くなりま
Once
すし、
the logistics get
ス
stopped,
ーパーやコンビニにも商品
manufacturing
が
will
届かなくなる
die, and
というところ
also
で、
the
ラストマイル、
supermarket
ミド
and
ルマイル、
convenience
スーパー
stores
倉
will
庫であっ
not
たり、
able
クロス
to
ドックであった
offer
り、
the
いろいろ
products to
な
the
要素があっ
customers.
て、
So
ま
there
あ、ある一
are
部分
last
に
mile,
自
middle
動運転という
mile,
のが当てはまってくるわ
warehouse,
けで
cross
す。
dock. There are a
で
lot
すか
of
ら
elements
物流全
that
体の効率化ということを考え
are
ますと、
important
ある一部
for
分
the
を自動運転
autonomous
にしただけ
driving.
では、まあ、
If
そ
we
れほど大
introduced
きな効果がない
autonomous
と
driving
いうことになります
to
の
the
で、
part of the
物流
entire
全体をです
logistics
ね、自動
systems,
運
it
転
doesn't
を
make
使っ
much
てどう
difference.
やっていっ
The
たら
entire process of
効
the
率が良くなる
logistics
のか、
has
全
to
体を
be
再設計し直
studied,
さなければならないと思ってい
redesigned
ます。だ
to
からここで重要になってくるのはやっぱり
become
データ
more
連携ということ
efficiency
だと思います。
using
で
AI.
それを使っ
And was
て
I
AI 等を
agree
使いな
that the
が
key
ら
will be
最
the
適
data
な物流
integration
システム
or
という
data
ことを考えてい
centralization.
か
We
なきゃい
should
けない
use
と。
the
これは
AI,
イスズ自動車は
apply the AI upon
いわゆ
this
るトラック
data
の製造業
to
ですし、
optimize the
油
logistics
純金
system.
さんは
We
サプラ
are
イ会
the
社で、
manufacturer
今お話しし
of
ま
the
した通り、
commercial
ラスト
truck
マイルであったり、
vehicles
倉庫
and
であったり、
applied
クロスドックっていうのは全く
intuition
違う
is a software company.
業界の方々なんですね。
And
だからそういった方たちといろん
last
な
mile
形で
warehouse,
連携
cross
しなが
dock,
ら、
there
日
are
本の物流っ
the
ていうものを、自動運
stakeholders
転を
from
うまく
different
使いながら
industries. We have
再
to
構築
work
していく、再
together
設計
with
していく、こうい
these
ったことが必要にな
ecosystem
ってきます。
in the
あり
ecosystem
がとう
of
ご
the
ざいます。
logistics
ちょっ
and
とお戻しして、杉
recreate
本さん、
the
商
autonomous
用車の方
world.
ではその物
杉本さん、
流の
in the
業界の
commercial
方と
trucks,
の連携も必要であるというお話、
they
今佐藤さんからあり
well
ましたけれど
Sato-san
も、
insisted
杉
on
本さん、
the
その
collaboration in the
パッセンジャー
ecosystem
ビー
is
コル
very
については
important.
その
What
あた
about
り
the
他
passenger
の業
vehicle?
界ですとか、
Do you
そういうところ
also
の連
work
携っていう
with
のはあり得るんでしょ
other
うか。
stakeholders in
連携は非常に
the
重要だと
ecosystem?
思っていま
Yes,
す。
we
も
also
ちろん
believe
そ
that
の
working
国
with
とも
the
そうです
different
し、いわゆる
stakeholders in the
ソフトウ
industry
ェア
is
テックカ
important.
ンパニ
Of
ー
course,
我々の
with
持っ
the
ていない
government and the
技
software
術だ
tech
とか、我
company
々
as
で
well.
は
If
ハンドリングで
the
きない
things
領
that
域
we
を
cannot handle,
パ
the
ー
things
トナ
we
ーシッ
cannot
プを組ん
develop,
で、しっかり
we
一緒
have
に
to
進んで
work
いく
with
と
those
いうこ
people
とが
who
重要だと
have
思っ
that.
ています。
And that's the
こ
key
れ、
for
この後の
making
テ
the
ーマでも少し
progress.
お話ししようかなと思っていたん
I
で
was
す
going
け
to
れど
mention
も、
this later, but
結局
maybe
で
I
す
should
ね、
say this now.
我々が今、自動運転というやりたいことに対してどういう技
Have
術を
this
持っていて、
dream of autonomous
何を持って
driving.
い
What
な
are
い
the
のか、ここ
technologies
の
we
差
have?
を
What are
ま
the
ず
technologies we don't have? We have
プロダ
to
クトを持っている我々が
identify
理解して、
what
我
we
々の
don't
持って
have
ない
right
技
now.
術を持っているパートナーさんを探
Then,
して正しくパ
accordingly,
ートナー
we
シ
have
ッ
to
プ
find the
を
right
結んでいきなが
partners,
らプロダ
establish
クトの
the
開発を進め
optimized
ていくという
partnership
ことが最も重
to
要
develop
な
the
だ
product
ろうなというふう
further.
に考えています。
So, knowing what we don't have
あ
and
りがとうご
work
ざいま
with
す。
the people who have that
Hearing
is
from
important.
perspective today, passenger vehicles from Nissan and commercial fleets from Isuzu. So, do you see the industry moving toward a shared software foundation that works all the across vehicle, all the types?
Yeah, absolutely. I think, like I was saying earlier, this technology is expensive. It's quite complex. It requires a very specialized knowledge, and so I think platform players will emerge, just like in the chip business. We're very much like that. We are a technology provider, and we provide in all these different areas. I think how the individual manufacturers, whether it's trucking, cars, defense, in agriculture, construction, mining, energy, any of these verticals, how they take chips or how they take, in our case, technology that's self-driving or platforms, how they apply it will be the differentiator. One way that I think about it is if you go to a manufacturing site, the different manufacturers will use similar tools, drills and conveyor belts and welding robots, but what comes out of the factory are very different. between an Isuzu or a Nissan or whoever it might be. And I think this is kind of similar. If you're a manufacturer, your ideal is just to get your customer the best product as soon as possible, as cheap as possible. And then it's a secondary question of, do you build it or do you develop it? Because it'll always be part of a much larger set of technologies, right? You're never going to buy everything from one company. You're going to buy from hundreds and thousands. That's the way the automotive industry and trucking industry work today. I think that's the way it'll continue to work. But in particular with self-driving, because the costs are so expensive, it will be platformed. What I will say though is I think over the next 5 to 10 years, these areas, self-driving and software-defined vehicles, these platforms and these technologies will become a lot cheaper. Just because, if you look at, like, for example, navigation systems in automotive, they used to command a lot of premium from consumers who would pay thousands of dollars for a navigation system. Today, virtually nobody pays that. That's almost expected to be for free. If you look at China, the same has happened with self-driving. So it used to be where you could charge thousands of dollars for a L2++ system. Today in China, you can't charge that much. And I think if you move forward, it'll be close to free. The same thing is going to happen in the rest of the world. So now if you're a provider of self-driving technology like us, or platforms like us, or tools like us, well, how do you survive if the price is approaching zero? If you look at China, the individual companies that are providing individual technologies actually don't survive. They have to end up doing many things. And I think for Applied Intuition, our strategy has always been build lots of products in lots of different verticals, so you can also ultimately take this expensive development cost and spread it across not 10 or 20, but hundreds of manufacturers all around the globe. Applied Intuition has offices in 18 places. We're going to open a couple of offices in the Middle East this year, so soon 20 plus offices. The reason we do this is to separate the cost across as much of the manufacturers and the operators of the world. And then that lowers the cost for everybody else.
Thank you, Kasar. You have a global perspective, so operating across Silicon Valley, Europe, and Japan. So what is the current status of intelligence and autonomy across the globe?
I would also add the Middle East into that group as a big region and that we play in. We don't have business in China, but China is also relevant to that question. I think these are the big, you could say, 5 centers. You can maybe put Korea in there as well. Each of the countries has a very different approach to AI. I think Silicon Valley, even in America, it's actually very, in Detroit, in Washington, D.C., in L.A., AI is not like in Silicon Valley. So it's even different within America. So the point I would make is it's very, very different across the world, but I think in our industries, specifically automotive and trucking, for the conversation today, everybody accepts intelligent machines are going to be the future. That's accepted by everybody. Nobody debates that. I think if we were having this conversation 5 years ago, if we were having the conversation 10 years ago, there's a lot more debate. So that's the case in the industries. Between the countries, or between the regions, there is some, let's say, different approaches. America continues to be leader in Silicon Valley. I think Japan, the understanding that AI will impact enterprises is there. But as an example, when I'm in Silicon Valley, everybody talks about AI all the time. It's not quite that big in Japan or in Korea. I think more so in China, impacting every single business. I think in terms of regions, the Middle East is the most AI forward in the sense of investing money and considering it to be important. I think there's many reasons for that, but I think central planning there is the GCC specifically. They are looking correctly at AI, which is like the Industrial Revolution, and we can't be left behind. I think I worry about Europe. I worry about Europe because the regulatory response to AI, unlike the Middle East where we need this, in Europe it's pushing it back. And that's going to be very bad for European companies. I think there are some good AI shops starting in Europe, and that's very good, and hopefully that will keep keep going. But that's roughly the situation. The last point I'll say on Japan specifically, because that's the topic today, is I would really underline for all the major companies in Japan, not only the ones on stage today, but the Sonys and the Rakutans and all of these companies, to make it a priority zero to build AI capabilities in-house. Because I think, especially the manufacturers, which are a big part of the Japanese economy, if they don't understand AI, they don't understand self-driving, that's very bad for the future of the companies, and therefore it'll impact the economic of the country.
Oh, I see, I understand. すいません、あまりお時間がないのですが、
Sorry, we are limited with the time, so I have a question to Sato-san and Sugimoto-san. This is about Japan.
今お話ちょっとネガティブなお話でもあったんですけれども、
a little bit of negative aspect related to Japan, but in Japan, innovation about the automobile autonomous driving, what do you think is needed in order to further accelerate? Starting from Sato-san.
なんでしょうね、技術の方はですね、もう
technology
海外で実現できてるわけですから、
has already been
これ
realized
は
outside
我
Japan.
々が
So
頑張れば
we just have to
実
do our
現できると
best,
思ってい
and I
ます。
think that
ま
part
た
is realizable.
国の方もです
However, when
ね、
it comes to the
自動運転
government
非常
side,
に
autonomous
後押ししてく
driving,
れている状
I
態
think
で
at
す
the
の
moment
で、
it's really supporting and
とに
pushing.
か
So
課
when
題
it
とかありま
comes
すけども、
to,
これも
of
クリア
course,
でき
there
る
is
と
an
思ってい
issue
ます。
related to the
あと残るはですね、やはり社
approval.
会重要
I
性
think
と
we are able
こう
to
いうところだ
resolve.
と思っ
And
て
I
います。
think the last part is about the
一般の
acceptance
こ
in
の
the
交通流の
society.
中に自動運
For
転という初
example,
めてのものが
the
登
autonomous
場してく
vehicle
るわけ
will be
で、
coming to the
自動運
general
転は
public
いわゆ
road.
るなんでしょうね、
Autonomous
法規
driving
を守って走りますから、
would
40キロ
actually
の道路は
follow
40キロで走るん
the
ですね。そうする
the
とその
traffic
実践の
rule.
速度の
If it's
違い
40
とかで、
kilometers, it
な
will
んか
be
遅い
40
なとか、
kilometers.
あるいは邪魔だなと
So
か
it
思われたりするこ
seems
とも
slow.
ありえ
People
ます
might
と。
think that the car is
ただです
running a
ね、
bit slow. That is
日本人
possible.
は
But the Japanese
こう何で
people
もその擬人化して可愛がる特性あります
has
よね。
the
戦車も戦
characteristic
艦も
of
全て
any
擬
sort
人
of
化
things
し
to
て
be
なんとなく愛情が湧くってあり
personalized,
ますので、
personalized.
馴
They
染んでいた
have
だければ
love
自動運転に
toward
対して
those
も
machines.
非
So
常に
if
温
they
か
get
い目
used
で
to
見
it,
守ってい
I'm
ただけ
sure
る
that
の
the
ではないか
Japanese
なと
people
思
would
って
accept
い
with
ます。
love.
そういった意味でも
So
あ
from
の
that
isuzu 自動車は
perspective,
今北海道に
we
19万
have
平米、東京ドーム4個分の自動運
90,000
転専用の
fourth
テストコー
worth
スを作
of
ってい
the
ます。
Tokyo Dome. This is a
一般
specific
的に
track
テスト
for
コ
the
ース
autonomous
での開
driving.
発っていうのは非常にクローズ
Development
の
on
規則性
the
の高い開発を行うん
testing
ですけども、
environment is
こ
actually
の
very
自動運
close
転の場所に関し
environment.
ましては、
But when it comes
オープ
to
ンイ
the
ノベーションの場
autonomous
として、
area,
参加
this is
各
open
いろん
innovation,
な方々
both
に
the
来て
academic
使って
and
い
the
ただきたいと思いま
industry
す。
and
そういった
also
中
the
で、
public sector. We
試乗
welcome
会であった
everybody
りを
to
催したりしまして、
come here
自
and
動
then
運
to
転って安
try
全なんだな、便利
so
なんだ
that
なと、
people
こ
can
う
actually
いうと
feel
ころ
that
を
the autonomous
確
driving
認
is
し
safe
て
and
い
it's
ただい
very
て、
convenient.
社会
I
実装
want
を高め
people
てい
to
きたい
think
と思
that
ってい
way
ます。
so that we be
そ
able
して
to be
日
accepted,
本の
this
場合は
technology to be
型式
accepted
認
in
証ですの
society.
で、
In case of Chimen, this is
なんでし
the
ょうね、
approval
できるか
by
らとい
model.
っていきなり
So
実路
if
で
it
無
can
人
be
で走らせ
done,
なきゃいけませ
we are
ん。
not
ですの
going to
で、
just
こうい
let
った
the
場を使っ
autonomous
て、
vehicle driving in the regular
関係
road.
第三者機関も
So,
含めてですね、
including
安
the
全という
third
ものをしっ
party,
か
we
り
want
確
to
認
make
して、
sure that we
世
can
の
check
中
the
に出してい
safety
く、
of
そうい
the
ったことを
autonomous vehicle
していこう
and
と
then
思って
bring
い
it
ます。
into the
で、先ほど言いまし
society.
た通り、
As I mentioned earlier,
ただ自動運転を社会実装
autonomous
するだけで
driving
は非常に
to
効果
bring
が
into the
少ないです。
society, I think the
そこら
effect
辺
is
その
limited.
物流全体あるい
The
は人流全
logistic
体
as
の
well
シ
as
ステムにおい
the
てさまざまな
total
ところ
system.
でさまざまな
We want
テクノロジーが必要になってきます。
because many technologies needed as we implement. I think what's important is to collaborate with many different groups so that we will be able to make the logistic system more efficient. I believe that Japan is the most safe and the efficient logistic system that can be achieved with the autonomous driving. So I do hope to be able to work together with many people and to create the logistic system. Thank you very much.
はい、社会重要性のところは
Okay, when it comes to acceptance in society, I think this is very important. Sato-san has already mentioned. I have a little bit message related to the technical perspective.
中短期的にはですね、
So for the
我々
mid
の予
to
想
short
27年とか
term,
20年代で考える
2027,
と、
or if you were to talk
今
about
は
2000,
強いテックカンパニーとパートナーシップを組む、これ
having
以
the
外にアクセ
partnership
ラレート
with
できる
these
方法はない
strong
と、途中に申し上げた通り
technical
考え
company, I
てい
think
ます。
we are able to accelerate. That's the
一方
only
で
way. But on the other hand,
少し
if we were to look at the future, much more from the mid to long term, in Japan, we need to have the software engineer to be able to build this system. For example, applied institution, when I talk with them, I envy them. They have wonderful numbers of the technical engineering system. I'm not able to do something similar with our current team. We have to catch up. And we have to have a partnership so that we are able to catch up to that level. We have to learn as we try to catch up, and if we do that, even if we were to accelerate, then we have to somehow depend on the other. We don't want to do that. So make sure that in Japan, we are a little bit behind, and I think we need to realize why we are behind, and then we have to also think of how we are able to catch up or even go above that. So we have to think more from the strategic point of view so that we are able to train people. Thank you very much. Sorry, we are time to close. So at the end,
could you give a little bit advice for the Japanese audience or Japanese automakers, whatever?
I think of all the talks that are happening today and at the conference, I think the most important one is the rapid adoption of AI within society. This is one part of that. So if I have any recommendation, it is as leaders of companies bringing in AI into your core workflows, and makers of products putting AI into the products, and as consumers using AI to make your lives better, I think is critical to the success of Japan long term.
ありがとうございました。本日は非常に重要な視点が共有されました。
I think we have been able to share a very important point of view. Autonomous driving is not is the social system itself.
皆さん今日はお忙しい中お集まりいただきありがとうございました。
Thank you very much for joining with us, and thank you very much for the panelists. Thank you very much, and please send them up with a big round of applause.
ありがとうございました。
Thank you very much.
Thank you so much.